Good morning, all of you. In this session, I am going to explain about simple problems on Lamys theorem, and also I will explain how to solve these two problems. Okay, in this session, I will explain how to resolve the forces for these two diagrams. Before going to the problems, first of all, you have to know the fundamentals about Newton's third law. For every action, there is an equal and opposite reaction. So here you can observe this is a horizontal support and this one a body. Okay, so W is the self weight of a body. So for our problems, we have to consider this self weight as a vertically downward force. Okay, so this W is a action force. Now here there is a contact between the ball and floor. So at the point of contact, you have to consider a reaction force. So here the support is horizontal. So you have to consider normal reaction. That means you have to draw a normal reaction force. Okay, this reaction force always makes an angle 90 degrees with respect to the support. Okay, here the support is horizontal. So you have to consider vertical reaction force. Okay, this vertical reaction force makes an angle 90 degrees with respect to the given support. Okay, this is the position of reaction. Okay, now you have to consider these two forces as a free body diagram. Okay, so this is the free body diagram for this given diagram. Okay, in similar way, if you are taking a block of weight W on horizontal plane, then you have to convert this diagram into forces diagram. Here already we know that W is the self weight of the body. So self weight of any body always acts vertically downwards, and this one is the reaction force. Already we discussed earlier. Okay, so here R is the reaction force. Always reaction force makes an angle 90 degrees with respect to the support. Okay, now this is the free body diagram for this diagram. Okay, here W is the self weight, that is the action, and R is the reaction. Okay, here you can observe this is a vertical support and this is a block. W is the weight of the block. So now you have to convert this diagram into forces diagram. First of all, you have to consider this self weight W, vertical force. Already we know that self weight always acts vertically downwards due to the gravitational force, due to gravitational effect. Okay, now here this is the vertical support. At the point of contact, you have to consider a reaction force. Okay, here there is a contact between the block and vertical wall. Okay, so you have to consider a normal reaction between the floor, so between the vertical wall and the block. Okay, here the support is vertical, so you have to consider horizontal reaction force. Okay, so already we discussed it. Now here reaction force always makes an angle 90 degrees with respect to the support. Here the support is vertical, so you have to consider opposite reaction force. Okay, now this is the self weight and this is the horizontal reaction. Okay, this is the free body diagram of this figure. Now this is the inclined plane. Okay, this is the block. Okay, W is the self weight of the block. Here theta is the angle of repose. Okay, angle of inclination of the plane with respect to horizontal. Now you have to convert this diagram into forces diagram. First of all, you have to consider given plane, given inclined plane as it is. Okay, now you have to consider this self weight W as vertically downwards. Okay, always self weight acting downwards, vertically downwards, and this is the reaction force. Already we discussed previous. Reaction force always makes an angle 90 degrees with respect to the support. Here the support is inclined plane, so you have to consider 90 degrees with respect to the inclined plane. Okay, so this reaction force always makes an angle 90 degrees with respect to the support. Okay, now this is the self weight and this is the reaction force. Okay, here this is a reference horizontal line. Okay, now this reaction force makes an angle theta with respect to the vertical. Okay, reaction force always makes an angle theta with respect to the vertical axis. Okay, this is the vertical reference line. So reaction force always makes an angle theta with respect to the vertical axis. Here the plane is inclined. So this inclined plane makes an angle theta with respect to horizontal. Okay, this reaction force makes an angle 90 degrees with respect to the inclined plane. So here the angle between this reaction force and the inclined plane is 90 degrees, and the angle between the inclined plane and the horizontal is theta. Okay. Now these are the important sign conversions to solve the problem. Okay. For right side direction, you have to consider positive sign. For left side direction, you have to consider negative sign. For upward direction, you have to consider positive sign. For downward direction, you have to consider negative sign. For couple forces, for clockwise couple, you have to consider negative sign. For anti-clockwise couple, you have to consider plus positive sign. Okay, these are the important sign conversions for solving the problem. Before going to the problems, you have to know the formula. You have to know the basics about Lamys theorem. Already we discussed in previous class. Okay, this is the statement of a Lamys theorem. Okay, Lamys states that if three coplanar concurrent forces, coplanar means the line of action of all the forces lie in a single plane. Okay, so coplanar means the line of action of all the forces should be lying in single plane. Okay, concurrent means okay, all three forces passes through a common point. Okay, so if three coplanar congruent forces acting at a common point are in equilibrium, each force will be proportional to the sine of the angle between the other two forces. Okay, so this is a force, origin force P, and this is a second force Q. The angle between these two forces are alpha. Now beta is the angle between second force and third force. S is the third force. Okay, beta is the angle between force Q and S. And gamma is the angle between force P and force S. Okay, these three forces are coplanar forces and concurrent. Okay, concurrent forces. Now you have to convert this diagram into already I explained the proof of Lamys theorem. So you have to convert this diagram, this forces diagram, into triangle. Okay, so from the triangle, the Lamys equation is P by sine beta equal to Q by sine gamma equal to S by sine alpha. Okay, this is the Lamys equation. Okay, here from this diagram you can observe force is always directly proportional to the sine of the angle between other two forces. Here this is the force P, these are the other two forces, so the angle between other two forces is beta. So force P divided by sine beta. Okay, in similar way Q is the force and S and P are the other two forces. Okay, The angle between other two forces is gamma. So force Q divided by sine gamma. Okay, in similar way, S is the force. So Q and P are the two remaining forces. So alpha is the angle between these two forces. So force S divided by sine alpha. Okay, from this statement, okay, each force is directly proportional to sine of the angle between other two forces. Okay, so this Lamys equation is very important for solving the unknown forces. Okay, now this is an example problem. For solving this problem, we have to use Lamys theorem. Okay, a ball of weight 120 newtons rests in a right angled groove as shown in figure. If all the surfaces are smooth, then determine the reactions at the points of contact. Okay, here the question is a ball of weight W equal to 120 newtons rests in a right angled groove. Okay, this is a right angled groove. That means the angle between these two inclined planes is 90 degrees. Okay, if all the surfaces are smooth, then determine the reaction forces at the point of contact. For smooth surfaces, don't consider friction. Okay, for smooth surfaces, you have to consider coefficient of friction mu equal to 0. That means frictional force F equal to mu R equal to 0. So for smooth surfaces, there is no friction between the contact surfaces. Okay, now here there are two contact points here, this one and this one. There are two contact points, so you have to consider two reaction forces. Okay, now W is the self weight of this ball. Okay, W equal to 120 newtons. First of all, you have to convert this diagram into forces diagram. Okay, so these are the two inclined planes. Okay, the angle between these two planes is 90 degrees. That means this is a right angled groove. Okay, and this one is a 60 degrees, this one is 30 degrees. Okay, total angle is 180 degrees. Okay, now this is a given ball. Okay, first of all, you have to consider a center point. Okay, after that, you have to consider a self weight W. Okay, already we know that self weight always acts vertically downwards. So you have to consider a vertical force, that is the self weight of a ball. Okay, self weight always acts vertically downwards. Okay, after that, you have to consider a reaction force at point of contact. Okay, here and here you have to consider reaction force. Okay, here let R1 is the reaction force between these two surfaces. Okay, now already we know that reaction force always makes an angle 90 degrees with respect to the support, and R2 is the reaction force between these two surfaces. This one also makes an angle 90 degrees with respect to this support. Okay, and here also 90 degrees. Okay, so already we discussed the previous reaction force always makes an angle 90 degrees with respect to support. Okay, now here you can observe there is a triangle. Okay, from this triangle you have to identify the angle between these two lines. Okay, here the angle is 90 degrees, here the angle is 30 degrees. The total angle is 180 degrees for triangle. So the remaining angle for this corner is 60 degrees. So this is 60 degrees. You have to consider here also same angle. Okay, for opposite corners you have to consider same angle. So here the angle is 60 degrees. So here this reaction force R2 makes an angle 60 degrees with respect to horizontal axis. Okay, in similar way, here you can observe this one also a triangle, right angle triangle. Here the angle is 90 degrees, here the angle is 60 degrees. So the remaining angle for this corner is 30 degrees. So you have to consider same angle here. Okay, so these two are equal. So this is a horizontal line, this one also horizontal line, so both are equal. Okay, now this reaction force R1 makes an angle 30 degrees with respect to this horizontal reference line. Okay, now you have to consider free body diagram of this problem. First of all, you have to consider horizontal and vertical axis like this. Okay, these two are the reference axis. After that, you have to consider this self-weight W, vertically downward force as it is. Now you have to consider this R1 and R2 reaction forces. This one is this one is R1. This one is R1 reaction force. This one is R2 reaction force. Okay. Now here 30 degrees is the angle between the horizontal reference line and reaction force R1. And here the angle is 60 degrees. Okay, between the horizontal reference line and inclined this reaction force R2. Okay, now you have to use this diagram for solving the unknown forces, that is R1 and R2 are the unknown reaction forces. For solving these two reaction forces, you have to use Lamys theorem. Okay, here there are three coplanar concurrent forces. Okay, so you can use Lamys theorem for this problem. Okay, from this diagram, you have to measure angle between two forces. Okay, so here now from this diagram you can observe the angle between these two forces is 90 degrees plus 30, that is equal to 120 degrees. So 120 degrees is the angle between self-weight W and the reaction force R1. Okay, total angle is 90 degrees plus 30, 120 degrees. And similar way, the angle between these two forces is 60 degrees plus 90 degrees. That means 150 degrees. And here the total angle between these two forces is 180 degrees. The total angle is 180 degrees. So 180 minus 60 degrees and minus 30 degrees. So 180 minus 90 degrees equal to 90 degrees. Okay, so the angle between these two reaction forces is 90 degrees. Okay, now you have to count these two angles. 90 degrees plus 120 degrees plus 150 degrees equal total angle is 360 degrees. Okay, now from Lamys theorem, angle between reaction force R1 R2 is 90 degrees, and the angle between reaction force R1 and W is 120 degrees, and the angle between force W and R2 is 150 degrees. From Lamys theorem, force is directly proportional to the angle between other two forces. So from Lamys statement, R1 is the force and 150 degrees is the angle between other two forces. So R1 divided by sine 150 equal to 120 degrees divided by sine 90 degrees equal to R2 divided by sine 120 degrees. Okay, so from this equation, from these two equations, you can get the value of R1. Okay, from these two equations, you can get the value of R2. Okay, first of all, you have to resolve these two forces for determine the value of R1. Okay, now you have to consider these two forces. Okay, as it is. Now you have to apply cross multiplication. After that, the reaction force R1 equal to 120 divided by sine 90 into sine 150 degrees. Okay, from this equation, the value of reaction force R1 is 60 newtons. Okay, in similar way, you have to consider these two equations as it is. Okay, Now you have to apply cross multiplication. The value of R2, reaction force R2 equals sine 120 into 120 divided by sine 90 degrees. Okay, from this equation, the value of reaction force R2 equal to 103.92 newtons. Okay, okay, this is the answer for this problem. Okay, so R1 is the reaction force. Here, this is the R1 is the reaction force, R2 also a reaction force. Now coming to the another problem. Two spheres, each of weight 1000 newtons and radius 25 centimeters, rest in a horizontal channel of width 90 centimeters as shown in figure. If all the surfaces are smooth, then determine the reactions at the points of contact. Okay, this is the given question. This is the given figure. Okay, here two spheres, each of weight 1000 newtons and radius 25 centimeters each, rests in a horizontal channel. Okay, horizontal channel of width 90 centimeters as shown here. If all the surfaces are smooth, then determine the reactions at the points of contact. For smooth surfaces, you have to consider zero friction. Okay, now from this diagram, first of all, you have to identify the forces diagram. That is, you have to draw free body diagram. So here this is a given horizontal support, and this is a left side vertical wall, and this one is a right side vertical wall. Okay, these are the two given spheres. Now W1 equal to 1000 newtons, W2 equal to 1000 newtons. Okay, this one is the self weight W, self weight of a lower ball. Okay, already we know that self weight always acts vertically downwards. Okay, now you have to consider reaction force for this contact point. Okay, you have to consider a reaction force at every contact point. Okay, there are four contact points here, 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 and here. Okay, totally there are four contact points, so you have to consider four reaction forces. Okay, so here the support is vertical, so you have to consider horizontal reaction force. In similar way, here the support is horizontal, so you have to consider a vertical reaction force. Okay, let R1 is the reaction force between the bottom floor, so floor and sphere. R2 is the reaction force between the vertical wall and sphere. Okay, in similar way, W is the self weight of a upper cylinder. Now R3 is the reaction force between the vertical wall and the sphere. Here the support is vertical, so you have to consider a horizontal reaction force. Okay, already we know that reaction force always makes an angle 90 degrees with respect to the support. Okay, so here the support is vertical, so you have to consider horizontal reaction. Here the support is horizontal, so you have to consider vertical reaction. Here the support is vertical, so you have to consider horizontal reaction. Okay, now here you can observe here also there is a contact between the two spheres. These two are movable surfaces, so you have to consider two reaction forces, equal and opposite reaction forces. You have to consider two equal and opposite reaction forces. So I am showing. Now you have to join these two centers. Okay, so this is the reaction force R4. Okay, R4 is the reaction force between these two movable surfaces. Okay, for this cylinder, you have to consider downward reaction force R4. For this cylinder, you have to consider upward reaction force R4. Okay, so this is the free body diagram for this problem. First of all, you have to consider this upper cylinder for determining the value of R3 and R4. Okay, after that, you have to consider this lower cylinder. Okay, for determining the value of reaction force R2 and R1. Okay, here this reaction force R4 makes an angle theta with respect to the horizontal. Okay, here angle also same. First of all, you have to calculate angle theta. Okay, from given data, the horizontal support is the width of the horizontal channel is 90 centimeters, and the radius of each cylinder is 25 centimeters. So from here to here the radius is 25, and from here to here the radius is 25. So the total length of this inclined line is 50 centimeters. Okay, now you have to consider a triangle, right angle triangle here. Okay, here you can observe this is a right angle triangle. Here the angle is 90 degrees, here the angle is theta. Okay, the remaining angle is 90 minus theta here. Here the total length of this slant edge is radius plus radius. Okay, radius plus radius is the length of the slant edge, and the length of this bottom side is 90 minus r minus r. Okay, that means here you from this diagram you can observe from here to here the value is radius, and from here to here the distance is radius. So the total bottom length is 90 centimeters. From that horizontal width you have to subtract this radius and this radius. Okay, 90 minus r minus r. 90 is the total width. Okay, total width of the channel. So here from here to here the distance is radius, and from here to here the distance is radius. Okay, so the length of this bottom side is 90 minus r minus r. The angle is theta. Okay, from this triangle you can observe the adjacent side is 90 minus r minus r. That means 90 minus 25 minus 25, that is 40, and the value of hypotenuse is 50. 25 plus 25 equal 50. So from this triangle cos theta equal to adjacent side divided by hypotenuse. So from this triangle theta equal to 36.86 degrees. Okay, this is the angle between this reaction force R4 and the horizontal support, horizontal axis. Okay, now you have to consider a upper cylinder. Okay, this is a case one. Okay, first of all you have to divide the given diagram into two cases. Okay, here I considered case one for upper cylinder. Okay, this is the free body diagram of a upper cylinder. From here you can observe there are three forces, so you have to apply a Lamys theorem. Okay, now you have to calculate angle between two forces. Here this is a horizontal force, and this is a vertical force, so the angle is 90 degrees. Now here the angle is 90 plus theta, so 90 plus theta is the angle between these two forces, and here the angle between these two forces is 180 minus theta. Okay, here you can observe the total angle is 180 from here to here. From this total angle you have to subtract this theta value. Okay, so 180 minus theta is the angle between these two forces. Now you have to apply Lamys theorem. From Lamys statement, each force is directly proportional to sine of the angle between other two forces. So R4 divided by sine 90 degrees, 1000 divided by sine 180 minus theta, R3 divided by sine 90 plus theta. Okay, so here 180 minus theta equal to 143.14 degrees. Here theta equal to 36.86 degrees. Okay, and 90 plus theta equal to 126.86 degrees. Okay, now from these two equations you can get the value of R4. Okay, from these two equations the reaction force R4 equal to 1667.05 newtons. Okay, in similar way you have to consider these two forces for determine the value of R3. Okay, from these two forces the value of R3, reaction force R3 equal to 1333.81 newtons. Okay. From case 1, we got reaction force R3 and R4 values. Okay. Now you have to consider a second case, that is a free body diagram of a bottom cylinder. Here, this is the free body diagram of a bottom cylinder. Okay, there are 4 forces. So we can't apply Lamys theorem. We can't apply Lamys theorem for 4 forces. Okay. So here, for solving these 4 forces, you have to convert this inclined force into horizontal and vertical component. Okay. Here, this is this reaction force R4 equal to 1667.05 newtons. You have to convert this inclined force into horizontal and vertical force like this. R4 cos theta and R4 sin theta are the 2 components. Okay. Now you have to resolve all the forces along the vertical axis. Okay. These are the 3 forces lying on the vertical axis. You have to add these 3 forces. Okay. Now, for upward action, you have to consider positive sign. For downward action, you have to consider negative sign. So, plus R1 minus W minus R4 sin theta equal to 0. From this equation, already we know that value of R4 equal to 1667 newtons and theta equal to 36.86 degrees and W equal to 1000 newtons. Okay, you have to substitute the value of W and R4 in this equation. Now, from this equation, you can get the value of R1. R1 equal to 2000 newtons. Okay. In similar way, you have to resolve all the forces along the horizontal axis. Okay, there are 2 forces. Okay, there are 2 forces lying on the horizontal axis. So, for right side direction force, you have to consider positive sign. For left side direction, you have to consider negative sign. Okay. So, plus R2 minus R4 cos theta equal 0. From this equation, R2 equal to R4 cos theta. Now you have to substitute the value of R4 in this equation. R4 equal to 1667.05 newton. Okay. So from this equation, the reaction force R2 equal to 1333.81 newtons. Okay. These are the 2 remaining reaction forces. Okay. So this is the complete answer for this problem. Okay, friends. First of all, you have to convert the given diagram into free body diagram. Okay, after that, you have to apply Lamys theorem or other method for determining the unknown forces. Okay. Okay. In next class, I will explain more problems on this equilibrium conditions. Okay. Okay, thank you.